In this video, we will talk about chemical reactions. Okay? Chemical reactions are when two different chemicals interact with each other and then change form in some way to make a new chemical, or many new chemicals. Okay? And just for the sake of our class, we're going to break down chemical reactions into four main types to begin with. Okay? The four easiest ones to kind of wrap your head around. Alright? Those four types are going to be single replacement, double replacement, synthesis, and decomposition. Okay? Now these are pretty simplistic names, and the reason we use them is because of the patterns that chemical reactions go in. Okay? So for instance, single replacement reactions are when you have two ions together, let's say A plus B, and you add in a new element, let's say it's C, and the C replaces one of the elements in the original thing. So you end up with AC plus B, or a single replacement. Okay? One of the ions is knocked off and replaced with a new element. Okay? Double replacement is the same idea, except in this one, AB would be paired with CD, and they would flip-flop each other. Okay? So A would pair up with D, and B would go with C. Okay? So it's kind of like I call it the switcheroo reaction. They switch places. Okay? Synthesis is where you take two smaller things. So let's say we've got, let's go M and N, and you react them together and they form a new chemical Mn. Okay? They combine together. They're synthesized. Okay? It means coming together, making something new. Decomposition is the opposite of synthesis, okay? And that's maybe where you have chemical OP and some process happens to it, and you end up getting O plus P. And as you can see, right, these are the four major patterns that go along with chemical reactions, okay? So there's one where we flip one out and change it with something else. There's another where we just switch both of them. There's one where we take two things and add them together, or maybe three things, or four things, or whatever you need. And then there's also decomposition, where you take one bigger thing and you break it into pieces. Okay? So those are our four main types. Okay? And when we do chemical reactions, we write them out in this manner. You write out whatever chemical is reacting, the reactants on the left. Okay, so the stuff you start with. You follow that up with an arrow that says that there's some sort of reaction happening. Something has happened to these elements. Maybe you heated them up. Maybe you added a catalyst, maybe you stirred it. Okay? There's lots of different ways to start reactions. And then on the other end, you get products. Okay? So in this instance, right, we have a single replacement reaction. As you see, we've got AB plus C equals AC plus B. Or in this situation, using actual elements, you have NaCl, so salt. We added in bromine. The bromine knocked the chlorine out of the way, and we got sodium bromide. Okay? That's a chemical reaction. The other major thing that goes along with chemical reactions is the charge, okay, of the particles involved. Okay? Chemical reactions are generally charge neutral, which means if there's a certain amount of charge on this side, there needs to be a certain amount of charge on this side. And generally the products are generally neutral. Okay, sometimes it doesn't happen. That's a little bit more complicated. We won't get to that until much later. Okay, these are just simple examples. So here, okay, I've got Na plus, okay, it's plus 1, that's its charge. Then I have S2 minus, that's its charge, because they are ions, okay. Those ions are going to come together and form a salt, sodium sulfide, okay. Well, sodium has a plus 1 charge, sulfur has a minus 2 charge. So that means we need to balance this out so we get a neutral product. Okay? That neutral product is going to be Na. It's plus 1, so we're going to need two of them, Na2 sulfide. Okay? This compound is neutral. We have two plus 1s and a minus 2. So it's a neutral compound, 0 overall charge. And we needed to put two sodiums in. Okay, when you have multiple of something, you put a subscripted number, not a superscripted number. It's a big difference. Okay, I mean two different things. Over here we have a double replacement reaction. We've got Na and chlorine reacting with potassium and oxygen. Okay? So we know they're going to switch places. Okay? The front ones are going to switch with each other. Okay? Remember, the front ones and the back ones matter in a compound, especially when they're ionic. So, sodium is going to flip with potassium. So what I'll do is I'll write sodium over here, give it a little space, put my plus, put potassium there. Okay? If they're going to switch places, sodium is going to end up being with the oxygen. Okay? Now, we should know from our ion table that sodium is a +1, and potassium is a +1. Chlorine is a -1, and oxygen is a -2. Notice that potassium oxide has 2 potassiums because you need to equal out the charge. It's a compound. So that means in our products, we're going to have an equal product as well, an equally charged product. So now we're going to need 2 sodium atoms with our oxygen to make that work. Okay? And then we'll also need to have, okay, just 1 potassium now with a chlorine, because that's going to be charge neutral. Okay? The next thing you're going to do with chemical equations is balance them. Okay? There are 2 potassiums over here, 2 sodiums over here. There's only 1 sodium here, 1 potassium here. There has to be the same amount of each thing on both sides. That's called not losing mass. Okay? In science, there's a key rule. It says that you cannot destroy matter. So that means if there's an atom of it over here, it has to end up over here. And if there's one over here extra, there needs to be one over here. So what we'll do is we're going to put a 2 in front of the compounds. That signifies that there are 2 NaCl's and 2 KCl's. And that means we have 2 NAs, 2 Cl's, 2 K's, 1 O, 2 N's, 1 O, 2 K's, 2 Cl's. We're balanced on both sides. That's called balancing an equation. Okay? And then in this final one, we have magnesium phosphate and calcium oxide. And I'll really quickly do this one. Magnesium is going to be with the oxygen now. Those are charged +2 and -2, so they're going to end up being MgO. Calcium is a +2, phosphate is a -3, so we're going to end up getting Ca3P2, so they charge neutral. Okay? We're going to have to make sure that we have enough calciums and manganeses, though. So we're going to put a 3 here and a 3 here. This is a balanced equation. Notice we have the same amount of each type of element on both sides, and they switch. It's a double replacement. There's going to be another video on balancing equations, but for right now I just wanted to get us started